Okay, so this is the free response middle problem here, question number 2, and it's another stoichiometry type problem when we have the letters A, B, and C. And so first one is to write the balanced chemical equation right here, and so we have 2Al plus 3I2 goes to 2AlI3. This is an I right here, iodine. And then it says determine the limiting reagent and the theoretical yield of the product if one starts with, and in letter A we have 1.2 moles of aluminum and 2.4 moles of iodine. And to determine the limiter, once you have your number of moles right here, divide by the coefficient. And so aluminum I'd divide by 2, iodine I'd divide by 3. Now if you can't exactly tell who's going to be your limiter, then go ahead and do it on your calculator. Which one's going to be smaller as your limiter? So divided by 2, that ends up being 0.6. And this one, 2.4 divided by 3 ends up being 0.8. And the smaller, the 2 will limit. So my limiter here in letter A is aluminum. And it wants to know the limiting reagent and also the theoretical yield of the product. And so my next step then is to use the mole-to-mole ratio with the limiting reagent. So I have 1.2 moles of aluminum to start with. And I will compare aluminum then, in step 3, my mole-to-mole ratio, to aluminum iodine, which is my product. And that's where I'm going to get my theoretical yield. And there's a 2 in front of the Al2I3, and there's a 2 in front of the aluminum right here. 2 to 2 ratio means that I have a theoretical yield of 1.2 moles of AlI3. That's my theoretical yield, and that's what it wants to know. Okay? In letter B, it's the same problem, but now I don't start with moles, I start with grams of each one. So I have 1.2 grams of Al and 2.4 grams of iodine. And so my first step now changes. Well, I'm sorry, second step, because my first step is to write the balanced chemical equation. I have to convert to moles. Here I did not have to convert to moles because I was given that. So I put grams in a position where it's going to cancel. Moles is my new set of units. And so in aluminum, there are 27 grams in a mole, as you can see right here, so 27. And in iodine, it's 127, 126.9, but we're around to 127. So 127 times 2 is 254. So there are 254 grams in this. So let's do the math on the calculator here to find the number of moles. 1.2 divided by 27 gives me 1.2 divided by 27 gives me 0.0444 repeating moles of aluminum, and 2.4 divided by 254 ends up being 0.009448, etc., and that's my moles of iodine. Now, to find my limiter, I have to do step 2.5 here, and that's divide by the coefficient. And so aluminum would be divided by 2, and iodine would be divided by 3. And I don't even have to do the math in this one because I know that this number is already larger than the amount of iodine I have. And if I divide it by 2, it's still going to be larger than if I take this smaller number and divide it by 3. So I can tell right now that my I2 is going to limit because that's going to be much smaller. So now that I know that I2 is my limiter, I can use that to do step 3 right here to get the mole-to-mole ratio and determine the theoretical yield of my product. So I have 0.009448 moles of iodine. Put iodine in a position where it's going to cancel, and then I put my AlI3 on the top, and for every 2 AlI3s, there are 3 I2s. And so I'll take my 0.009448, multiply that by 2, enter, divide that by 3, enter, and I end up with 0.0062991. If I wanted to round this to 3 sig figs, know that these zeros don't count, so I'd go to my third one and I'd say 5 or more. Yes, round up. So this one would become a 0, this one would become a 3, this would be a 6, and 0.00 right here would be my answer for my theoretical yield of moles of ALI3. The last question in example number 2 is, how many grams of our aluminum are left over in part B? So this is just like I did in the very first example problem. To find the leftover, I take my limiter, so 0.009448 moles of iodine. And now I compare that to my excess reagent, when in this case it's aluminum, to find out how much aluminum I'm going to actually need. And so aluminum has a 2 in front of it, iodine has a 3 in front of it. So let's take this 0.009448 and divide that by 3, and then multiply that by 2, and I end up with 0.00629,866, a few more numbers right there. And this is my moles of aluminum that are actually used up. Now, I have to find the difference between this and the amount of aluminum that I started with. And this is the amount of aluminum that I started with. Start, and this is my amount that's used. And so I have to find the difference, which means subtraction. And so I'm going to do this on the math, on the calculator here. I'm going to do second. Oops, I'm going to do negative second answer. So I'm going to get a negative of that. And I'm going to add that to my 0.0444. And so my amount of aluminum left over is 0.0381 to 3 significant digits moles of aluminum. Now, if they wanted to know that in grams, you'd have to convert it to grams yet, but that'll get you to the number of moles, and you can always do the converting later.